All right, so this is the 4-7 warm-up. I'm just going to work through it with you guys. And then obviously answer any questions because obviously I wasn't here yesterday to teach it. So if you have any questions on 4-7, today would be your opportunity to ask and the rest of the sections. Tomorrow, at the end of the class period, I'm going to give you a little blank unit circle that you can choose to fill in as much or as little as you want. Obviously not with like your stuff out. You'll clear everything off. And then I'll give you the same opportunity like you did the first time. You do not need to completely fill it in if you don't want to. You don't have to fill in every coordinate point. Like, it's up to you if you want to fill it in completely. You can do the original unit circle, and then you can also add on the tangents. Like, I would say I'll let you do that stuff, and then I will give it back to you on Thursday. Honestly, you could do this day of the test, but you wouldn't have enough time to do both. So I'm just going to give it to you the day before. Hopefully, the idea is if you do this one more time, you may not even need it Thursday. That's kind of the goal, is that you're doing it so many times that it's like on permanent memory in your brain. But if not, you can use it again on the test on Thursday. All right, so if you had this already filled out, it obviously makes this section a lot easier. Like I just said, I would say you could fill in your sine, your cosine, and then you can also come back in here and fill in your tangent. Like if you wanted to just write it to the side, that you can. If you wanted to write it on each coordinate point, you could too. It's totally up to you what you do here, okay? But the tangent at the over 3 is root 3, the tangent at the over 4 is 1, and the tangent at the over 6 is root 3 over 3. Obviously, the signs change as you move around your circle, but those are the main 3 special angles. And then at 0, it's 0, and at pi over 2 and 3 pi over 2 or negative pi over 2, it's undefined. All right, so it says for number 1, find the exact value of cosine of negative 1. First of all, these are restricted, right? Like, so when we're doing cosine, where are we looking? First and second quadrant. So cosine is your natural first and second quadrant, okay? And tangent and sine are first and the negative of the fourth quadrant. So that would be the negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So if you're looking for the cosine to be negative 1, I'm looking for where in my restricted part my x is negative 1, which happens where? Pi, good. Pi is where cosine would be negative 1. The second one says find the exact value of tangent negative or tan negative 1 of negative root 3. So where is tangent negative root 3 in the restricted area that we want to use? Negative pi over 3. Good. Then 3 says find the exact values of cotangent of cosine negative 1 of 1/2. Because that is a unit circle based coordinate point, you can actually use your unit circle to find the cotangent, or you could set up a triangle. You could do either way. If it was something like 3/4, you'd have to use a triangle, okay? But because it's 1/2, you can either use the unit circle or you can use a triangle. So I'll do it both ways. So the first one is if its cosine is 1/2, then I'm looking again for where x is a positive 1/2, which happens at pi over 3. And then I'd want to find the cotangent at pi over 3, which would be root 3 over 3. That's one way to do it. The other way is use a triangle. Put theta in the corner. We don't know theta, but we know that the side adjacent to theta is 1 and the hypotenuse is 2. So then to find the missing side, I do 1 squared plus x squared equals 2 squared. 1 plus x squared would equal 4. X squared would equal 3, and x would equal the square root of 3. And then cotangent is adjacent over opposite. So this would be 1 over root 3, which rationalizes to root 3 over 3.
If there was like a pi in it and we couldn't find it on the unit circle,
then you have to set up a triangle. Mm-hmm. Yep. This is positive. Well, it depends. Either of them. This would be positive and this would be positive. The cosine, you only look in first quadrant and second quadrant. Oh, yeah. So to find the initial angle, it's that, right? And then you would find the cotangent of the positive angle. Inside first. Yep. Yep.
How do you find the second one? Like, I know that you look for negative square root of 3.
Which is pi over 3, and then that's this whole answer. So then it becomes cotangent at pi over 3.
No, for the second one.
Oh, you're looking for where tangent's negative root 3.
Yeah, where did you find that? I might just not be
It's negative. So, I just wrote the tangents over here. I didn't write them everywhere.
Oh, because it's tangent.
But it's tangent, yeah.
Wait,
Oh, can you zoom into that?
What part?
The tangents.
I thought the bottom part was the tangents.
What do you mean the bottom part?
The thing that you wrote, this.
That's the angles to use for tangent. Those are the negative angles. None of the actual trig functions will ever have a pi in them. Like, so the cosine of something, the tangent of something,
No, I'm talking about these things.
right.
That's tangent, right? Of those angles.
I didn't write them on this though. I wrote them at the top.
Oh.
That's all. Yeah. Those are the tangents. If you wrote them there. This is the negative name of this angle. This is the negative name of this angle, and this is the negative of this angle. Because for inverse, we had to use from that quadrant, right? It can't jump. So we have to use from negative pi over 2 to positive pi over 2. But the trig values for tangent are the ones I wrote up here. I just didn't write them all the way around the unit circle. You can if you want to, but I just didn't for time purposes. Okay, what was the homework question? So you got to find this first, right? So 5.
At the time, I didn't know that over 2 you could find it.
Yeah. So 5, because that would be 2 and 1/2 pi, right? That's at the top. So that's 0, 1. So that's, the cosine would be 0.
Yeah, I put that.
Our cosine of 0. Now you're saying, give me the angle in which the cosine's 0, so it's the same.
So it's pi over 2.
It's pi over 2, right? Because it's your initial restriction.
It was 0. Like, I wasn't finding the angle.
Mm-hmm. All right, this is what you wanted to download again from Canvas. This is on the module underneath where it says review. It kind of goes section by section. So we're going to do this like topic-based wise, and then the PDF is where all the practice problems are going to come from. So 4.1 was the start of all this stuff, right? The radian and the degree measure. What is radians? How do I get back and forth from them? The complements, the supplements, the coterminal angles, and the arc length. It was all from 4.1. So to go from radians to degrees, we're going to take theta and multiply it times 180 over pi. To go from degrees to radians, you're taking theta and multiplying it times pi over 180. The complement are two angles that sum to 90 degrees or pi over 2. So to find the complement, if it's in degrees, we do 90 minus theta, and the supplement would be 180 minus theta. And then in radians, it's pi over 2 minus theta. And pi minus theta. And these are the ones that cannot be negative. So if it's bigger than 90 or bigger than pi over 2, then we would say there's no complement. And if it's bigger than 180 or bigger than pi, then we would say there's no supplement. The coterminal angles are the ones that have the same measure but go around the circle more times or less times. So if I want to find the coterminal in degrees, I take theta and I add or subtract 360. If I want to find it in radians, I take theta and I add and subtract 2 pi.
And these are allowed to be.
These could be negative. Yeah, the negative one had to be negative. The positive one has to be positive. So remember, sometimes you got to go more than once. Well, if it's the negative coterminal angle, it has to be negative. And if it's the positive angle, it has to be positive. And then arc length. Arc length would be S equals theta times the radius. That's our SOR. And this time theta has to be in radians. So the first thing, and most of you did okay on the quiz, there are still people that forgot to convert it. So you have to make sure you convert that into radians, and then you just multiply it times the radius. And I could give you any two of those three things and ask for the other one, so you might have to work backwards to solve. Just pay attention to what you're looking for. This you won't have a calculator for. So nothing on this page you'll have a calculator for. It would not matter, but those you would keep exact.
What do you mean you can give it to?
Came forward 2, and this was the start of the unit circle. So obviously we learned how to fill in the unit circle. You're going to need to know how to find the points and the trig functions from an angle. So I could give you any angle that's unit circle based. It could be coterminal, it could be not coterminal, okay? It could be original unit circle, but then you'd have to be able to find it. So we're talking all the over 2s, over 3s, over 4s, over 6s, or the whole numbers. Remember, your even whole numbers are on the right, your odd whole numbers are on the left. And all students take calculus tells you which of your original trig functions are positive in those quadrants. So this would be any of those, and again, it could be on your original unit circle or it could be coterminal. And it will either ask you to identify the coordinate point there, or it would ask you to identify the sine, the cosine, the tangent, the secant, cosecant, cotangent, any of those or all of those. It might ask for all 6, and you should be able to find them. Now this is where that multiple choice is going to get you if you're not careful with your signs. Like on the quiz, if you got the wrong signs but you had the right value, you got partial credit, and now it's going to be all or nothing. So you have to be very, very careful.
How would you get the wrong sign?
Because you grabbed the wrong quadrant. Like if I gave you any over 6, you should know the coordinate point there. So if I said like 17 pi over 6, right? You already know the coordinate point is root 3 over 2 and 1/2, right? So this is my cosine, this is my sine, and my tangent would be root 3 over 3. That I should know automatic because it's an over 6. But then I have to figure out what quadrant it lies in to know what positive, negative signs those are. So I would take 17 divided by 6, and I'd get 2 and 5/6. Remember the even odd, so the even is here. That means that's 2. 5/6 means it's past the halfway point and in the second quadrant. So I, from there, would know that the cosine is negative, the sine is positive, the tangent's negative, and then depending on what it asks for, then you've got to grab it. But if the answer's positive 1/2 and you put negative 1/2, there's no partial credit because it's multiple choice for this part.
Aren't you able to just look at the fraction to know which quadrant it's in?
Yeah, like what we just did.
Like you don't have to do the go start on the even side. Go.
Because it's 2, you mean? Because it's a coterminal? What, I don't know.
You know how you did like you start on the even side and you swing the arrow?
Yeah.
Can't you just know that's on the second quadrant because it's 5 pi over 6?
But what if it was 3 and 5 pi over 6?
Oh, okay.
Right? That's what I mean. That's why you got to know where to start. Yeah. Questions on that? Yep.
What's the rule that goes over the?
So if it's smaller than 1/2, it stays in the first quadrant after it, like wherever you start. If it's bigger than 1/2, yep, the fractional part of it. So the whole number part tells you start on the right or start on the left. If it's smaller than 1/2, you stop in the first one after that point. And if it's bigger than 1/2, you go past the y-axis. Yep.
What would you do if it was a whole number?
If it was like 21 pi, that's odd. That's on the left. So my coordinate point there is -1, 0. Any evens on the right, every odd's on the left. I would not want to go around the circle. Yeah,
So
no.
it's 22 pi be 2, right? And be 1, 2.
It'd be 1, 2, right. Okay, then this part is the calculator-based part, okay? This is still multiple choice, but it is with the calculator. So you'll start with this part. You'll get a calculator at the beginning. You'll do, there's less with a calculator than without. This is where you've got to pay attention to your mode because you're going to have to switch back and forth. So if I had this question first, sine of 2.4, what mode's my calculator going to be in? Radians. There is no degree symbol on there, so it has to be in radians. And then that's obviously just sine 2.4. 0.6755 if it said to round to 4 decimal places. Cosecant of pi over 7 is 1 over sine of pi over 7. That's also still in degrees. I mean in radians, sorry. 2.3048. And then for cotangent of 23 degrees, 15 minutes, 48 seconds, we go back to degrees.
Could you write it as sine 1 over pi over 7?
No. Then you're reverting the angle, not the trig function.
So,
You'd have to find the sine of it and then do 1 divided by it if you did it in multiple parts. But you can't do sine of 1 over, because it's not the angle you're saying is the reciprocal. It's the trig function. 1 divided by tangent, 23. Make sure you know where your degree and your minute and your second notation buttons are.
this is in degrees, right?
This is in degrees, yep. 2.3261. This is why it's so important to be practicing with whatever calculator you're planning to use on Thursday. Don't be trying to figure out a new calculator the day of the test. There's a little bit more of the calculator part, but we'll come back to it because now we switch back to non-calculator. So your even and odd functions, remember that cosine and secant are even and all the rest are odd. Sine, cosecant, tangent, and cotangent. And they are even because even if you change the sign on the angle, it doesn't change the sign on the trig function. So if I have cosine of t equals 1/2, then cosine of negative t also equals 1/2. I don't change the sign. So then, and then secant, again, let's say now secant of t is positive 2, then secant of negative t stays positive 2. So even though you change the sign on the trig function, it doesn't change the sign on the, even though you change the sign on the angle, it doesn't change the sign on the trig function. Everything else changes the sign. So if I had the sine of t was 1/2, then the sine of negative t is going to be negative 1/2. We would change the sign. Same thing for cosecant, tangent, and cotangent. So these are all odd because they change their signs. So everything else changes sign except for cosine and secant. All right, then came 4.3, which was right triangle trig. Again, this is part without the calculator, and like the word problems would be with. So obviously the word SOHCAHTOA is important. We need to know that sine is for opposite over hypotenuse. You need to know that cosine is adjacent over hypotenuse, and you need to know that tangent is opposite over adjacent. And then you need to know all the reciprocal functions as well. So the cosecant would be hypotenuse over opposite, the secant would be hypotenuse over adjacent, and the cotangent would be adjacent over opposite, because it could ask you any of those. So now you can see something like this. Find the trig functions given one of the, find the remaining trig functions if you're given one of them. So this one says the cosine of theta is 2/5. This is when you have to use a right triangle. 2/5 is not on my unit circle, so I would have to set up a triangle. Theta's in the corner. 2/5 would be a 2 on the adjacent side, a 5 on the hypotenuse, and then you've got to find the remaining side. So 2 squared plus x squared would equal 5 squared, 4, 25. X squared would equal 21, and x would equal the square root of 21. That breaks down into 3 and 7, nothing repeats. So this would stay square root 21. Now, unless it gives you other information about where this angle is located, like something else is negative because it's in this quadrant, whatever that is, you assume it's in the first quadrant. So in the beginning, we put them all in the first quadrant, and we didn't worry about the signs. So then from here, the sine would be the opposite over hypotenuse, so square root 21 over 5. The tangent would be opposite over adjacent, 21 over 2. The secant is the reciprocal of what they gave me at the beginning, 5 over 2. The cosecant, reciprocal of sine, so 5 over root 21, which is going to get rationalized. And the cotangent, reciprocal of tangent, 2 over root 21, and it gets rationalized. It may ask you for just one more of them. It might ask you for all 5 remaining.
Miss Kristen,
Yeah.
I saw somewhere that like if you're given a question, like the generic triangle that you have to draw is like facing that way, right? Like how you drew it.
Yeah.
Because if you draw it somewhere else, like facing another way, won't it change everything?
Well, that's why. So in the beginning, we didn't move it around the unit circle. We didn't technically do that till 4-4. And that's where it will give you another piece of information, like something's positive, something's negative, in this quadrant, that kind of thing.
But normally, if
If none of that's given, it's first quadrant.
like with no sign.
Correct.
Okay.
All right, special right triangles came next. So this was your 30, 60, 90, and your 45, 45, 90 triangle. 30, 60, 90. Oh, that's hard to read, sorry. This would be A, this would be A, root 3, and this is 2A. And then 45, 45, 90 is A, and A, root 2. So you can use this unit circle based. Your radius would be the 1, or the A would be the 1 there. But you have to use it if it's not unit circle based. So if I give you side lengths, like one of the side lengths is 5, I can't use anything for my unit circle. I have to use these. Our Pythagorean triples. So these are the things that are going to save us time. 3, 4, 5. 6, 8, 10, 5, 12, 13. Those are the most popular. 7, 24, 25, and 8, 15, 17, I would say, are the next grouping in popularity. And then cofunction. Oh, man, I didn't realize I had a typo. That's spelled wrong. These are trig functions that come in pairs that give you the same values, right? So sine goes with cosine. And those are interchangeable. So sine goes with cosine, cosine goes with sine. Cosecant goes with secant.
Can you give an example of that?
Mm-hmm. And tangent goes with cotangent.
Can you leave it there?
Mm-hmm. And then if it's in radians, all those 90s get replaced with pi over 2. So there's 2 parts to this. You're finding, obviously, the pairing, the match. Sine goes with cosine, secant goes with cosecant, tangent goes with cotangent, but then you're finding the complement. So if I asked you to find the cofunction with the same value of cosecant theta, no, sorry, not cosecant, cosecant of 40 degrees, this is going to be secant, because those are a pair, and the complement to 40 degrees, which is 50 degrees. If it was in radians, it could be something like the tangent of pi over 3, and this would equal the cotangent of pi over 6. So the 2 parts are the pair that go together, the trig functions that go together, and then the second part's just the complement. And this is always true because if you're looking at tangent and cotangent, one is adjacent over opposite, one's opposite over adjacent, right? So if I did the opposite over adjacent, if I looked at my triangle, if this was pi over 3, which would be 60 degrees, then this would be pi over 6, which would be 30 degrees. So whatever the tangent is at pi over 3, whatever this opposite side is, and this is my adjacent side, the opposite side over the adjacent side for pi over 3 is going to be the same as the cotangent of pi over 6, because it'd be opposite and adjacent that way. And then you had the word problem. So these are your right triangle trig problems. The angle of depression, the angle of elevation. Okay, plus what, like if they actually wanted you to find the angle, that could be in this section too. If I gave you a triangle and I told you that the horizontal distance was 215 feet and the vertical distance in some way, not necessarily just the words vertical distance and horizontal distance, but that, and I wanted to find theta, this is where your inverse trig functions come into play. This would be the tangent of theta would equal 325 over 215, and then we tan -1, whatever is given. These word problems are going to be in degrees. Those would be on the calculator part.
All of them are gonna be repeat the word problem?
Yep. Well, these, the right triangle trig word problems.
Yeah.
Yeah. Then you had the oscillating like spring, that's radians. Yeah. This is elevation. This is depression. You're welcome. So horizontal down is depression. They are the same value though because they're alternate interior angles. So you just can't put it here.
So elevation is straight down,
Elevation's ground up.
ground to the top.
Yep. Or wherever you're standing up, because it may not be ground. All right, 4-4 was after the quiz. So everything from here on out was after the quiz. So 4-4 is your trig functions of any angle, okay? We did do some of it beforehand, like that whole, like if it was 17 pi over 6 and you had to find it, that's the same idea. You're just moving all around your unit circle now, okay? You also had stuff like the points on the terminal side of an angle in standard position determine the exact values of the 6 trig functions. So if I have -6 and 8, now the direction I'm moving matters because I have it's signed, right? So -6 means I'm moving left, up 8, and then my angle, let me put the 6 on the outside. Theta would be in this corner. It's always between the end of the angle and the x-axis. So if I wanted to find all 6 trig values, I'd complete the triangle. What would be on the hypotenuse? 10, it's always positive, right? And then I could find all the trig functions based on that. So sine would be 8 over 10 or 4/5. Cosine, -6 over 10, -3/5. Tangent, 8 over -6, -4/3. And then all the reciprocal stuff. So flip it. Cosecant, 5/4. Secant, -5/3. And cotangent, -3/4.
How do you know, like, the way I first drew it, I put the 8 on the other side.
You can't because it's +8. So the 6 is negative, which means you move left.
So, I put the, I put the triangle, what if
Theta's here. If it's here, theta's here. If it's here, theta's here. So it's always got one side as the x-axis. They're not because you're standing there. Reference angles. All right, so as you move around your circle, right, you got to figure out your reference angles. If they are in the first quadrant, theta is equal to theta prime, right? If it's pi over 6, pi over 3, pi over 4, any of those, we keep it as those. As you go in the second quadrant, it would be 180 minus theta or pi minus theta. If you're in the third quadrant, it's the other way around. So theta minus 180 or theta minus pi. And in the fourth quadrant, it's 360 minus theta or 2 pi minus theta. What's the trick if it's one of your specials, though? If it's over 4, over 3, over 6, or over 2, what's your reference angle? Just pi over it. Have a good day. You're welcome. So over 3, over 6, over 4, over 2, your reference angle is pi over whatever the bottom is. Only if it's something else would you have to figure out what quadrant does it lie in and find it. it's 180. Yeah. And that's the importance of knowing those coordinate points, right? Because all those reference angles are how you figure out what your sine, cosine, and your tangent are.
Right, so if it's tangent.
You're welcome. And then the word problem, so I just screenshot it and pulled it back in here. This is the same word problem that was from the notes. This was 4, this is example 11. This is there's a spring, right? And all you got to do is plug the value in here. But it's important to be in what mode in these kinds of questions. These are in radians, okay? There is no degree in that equation. So you literally just take your value and plug it in. You will have a calculator for this one. So if I just wanted to find it at 1/4, where t is 1/4, I would just do 2 sine 6 times 1/4. And you could do the 6 times 1/4, then find sine, then multiply by 2, or you could type that whole thing in. Okay, then came all the graphing. So we started with sine and cosine, okay? And remember, you're going to get either sine, you're going to get 3 of these, either sine or cosine. And then you're going to get the other one's reciprocal. So you're basically doing both sine and cosine. And then you're either going to get cotangent or tangent depending on your version. So the sine and the cosine, we find the amplitude. So this is absolute value of A. We find the period, which is 2 pi over B. We find the 5 key points, which would be 0. And then the period times 1/4 times 1/2 times 3/4. And then the last one is the period. Those will be marked on your graph. Okay, so that there's going to be a little line for amplitude. There's a little line for period. And then it's going to say mark the key points on your x-axis. You'll mark those. It's going to ask you if there's a phase shift. So this is where you set bx minus c equal to 0 and solve it. If it's positive, then we go back and add those points. If it's negative, we go back and subtract those points. Then you're going to plot all those points, identify if there's a vertical shift, and make sure if it is, you're going to shift it at the end. So find your key points and then shift it.
So you do the key points and then you find out if there's a phase
If there, well, I mean, it doesn't matter if you find out there's a phase shift first and then do the key points. Like that order doesn't matter. You just wait until after you find the phase shift to add that onto the key points.
Okay.
Yeah.
Is the equation y equals sine or cosine bx?
It's y equals a sine bx minus c. And technically that vertical shift is d. Or y equals a cosine bx minus c. And again, vertical shift would be d. Be prepared, like in somewhere in those 3, you're going to get a phase shift. In somewhere in those 3, you're going to get a reflection. In somewhere in those 3, there's going to be a change to your amplitude. You're not getting just one of those things in each one. Like it's not like there's just a vertical shift on, and that's it. It's not, there's just an amplitude shift. It's going to have multiple parts. And then remember your sine curve starts at 0, goes up, down, up. You're doing 1 period, and then the cosine curve starts at the amplitude, down, up. And again, you're doing 1 period. All right, then came tangent and cotangent. So the tangent, you're going to find, again, the amplitude, which is just your A, okay? That really doesn't have an amplitude. That just tells you how high up and how low to go on those quarter points. So this would be A, tangent, bx minus c. And then again, there could be a vertical shift. The period is now pi over b, not 2 pi over b anymore. For tangent, we find the asymptotes by doing bx minus c equals negative pi over 2 and bx minus c equals positive pi over 2. From the one on the left, you subtract the period. To the one on the right, you add the period.
Once you find that.
Once you find whatever that is. Yeah, once you solve for x. And then those will be your 4 asymptotes. There's going to be a line on your test that says, like here, find your asymptotes, list your asymptotes, which you're going to make sure you make x equals because those are equations. And then you plot those. You find the you find the halfway point.
2 minus the period.
The one on the left minus the period, the one on the right plus the period. Yeah. And then you have to find exact way in between those half points. Those are your zeros. You eyeball the quarter and 3/4. You mark whatever A is. And for tangent, you go up to the right and down to the left. Negative tangent would be flipped. Yeah,
So do you always set it equal to -pi/2?
for tangent.
Always?
Yeah.
And then after that you subtract your period?
Yep.
So it's first set equal to those two.
Yep.
And then you subtract the period.
Yep.
And if there's no minus c, we just put
Whatever bx is there. Yep.
Wait, there's no minus what?
If there was nothing here. So if it just said tangent of pi x, let's say, this gets set equal to pi over negative pi over 2 and positive pi over 2. So cotangent is almost the same. The biggest difference, so amplitude is still the same. This just gives you your A, which is your quarter point and your 3/4 point. The period is still pi over b. The asymptotes we set equal to 0 and pi. That's one major difference. And then you still do the same thing. From the left, subtract the period. To the right, add the period. Those are going to be your asymptotes. Yeah. It's okay.
The negative of tan is which?
Goes up, left, down, right. So everything's the same except the actual curve starts up, left, down, right.
But then I thought cosine.
That's the shape of cosine, but the asymptotes would be at different spots because the asymptotes come from 0 and pi. So then you'd go up, left, and down, right with cotangent. You do the same thing. You find that quarter point, eyeball quarter, 3/4, and mark A. And then again, cotangent starts up, left, and comes down on the right. Yep. No, that's an asymptote. You mean my actual writing here?
Yeah.
This is 0 and this is pi. Yeah. The zeros, yep. And again, you're either going to get tangent or cotangent. So you're going to get sine or cosine, you're going to get tangent or cotangent, and then whichever initial function you got. So if you got sine, you're going to have to graph the reciprocal of cosine. So if it's sine, it's going to be sine and secant. If it's cosine and cosecant, because you're going to end up having to do both.
So to find the zeros, you add them together and divide
Right.
them.
Yep.
And then you
All right, then the last two were cosecant and secant. So for cosecant, you are graphing sine. You're going to draw the asymptotes where the zeros are. You're going to extend it one more half period because you need 4 asymptotes and 3 curves. So that's for tangent, cotangent, secant, and cosecant. You need 4 asymptotes, 3 curves. If there's a vertical shift, remember you want to find the asymptotes first and then shift it. Otherwise, it'll be super confusing where to find the asymptotes. So if there's a vertical shift, like think about what would happen, right? So if this is sine and I graph it and I shift it now, your asymptotes are no longer where it touches x. Your asymptotes are where it did touch x. So you want to find your asymptotes down here before you shift it. Then shift it, then do your parabolas. Does that make sense? Yeah.
So if we need an extra asymptote, and if we just go to the left,
Yeah, you can go either left or right.
we could just use,
You're just eyeballing.
we could just, eyeball.
Yeah, you don't need, for the extra one, just do the spacing, mark it, do it. You don't need you don't need exact. All right, then secant, you're graphing cosine. You're doing the same thing. Graph cosine. This time, my graph would look something like this. my asymptotes before I add the sides on are only 2 for cosine. So I'm going to drop both sides here and draw the additional asymptotes and then draw the parabolas. You do not need to erase your initial one, okay? But obviously don't forget your parabolas. Like I've seen people go all the way through it and leave it as sine or cosine. You don't want to do that. And each of that's going to, like those points are either 8 or, those questions are either 8 or 9 points and they'll be broken down amongst that stuff. So like the amplitude might be 1 point, the period might be 1 point, the key points might be 2 points, depends on what it is. And then we end where we started today. Okay, inverse functions from the unit circle. So this is where it's going to be beneficial to fill out what you can on that unit circle. I would definitely add the tangents. You can even add a note for yourself that this is cosine and that this is sine and tangent. And you can add the negative angles on if you want. Like you could do all that tomorrow and then add the tangents on. Like I would definitely say over 6. I would do the same thing. Either fill in all the coordinate points or do your over 6 is root 3 over 2 and 1/2 and tangents root 3 over 3. Your over 4. Sorry, I ran out of space. I should have done it all at one spot. And the tangents 1 and the over 3. I would recommend doing that instead of filling in every single coordinate point. But if you want to fill in every coordinate point, go for it.
Over 2 is undefined.
Over 2, tangents undefined. Yep.
Zoom into the top, is that for 6?
The top is over 6. Yeah, over 6 is root 3 over 2, 1/2. And then the tangent would be root 3 over 3.
Wait, all over 2s are undefined?
Tangents undefined.
Does that say square root 3 over 3?
Yeah. And then the inverse functions with using a calculator. So if I said the tangent of theta is 0.526, find theta. That's where you're using a calculator. It would be tan -1 of 0.526. Or inverse functions using the triangle. That's where you'd set up your triangle. That was kind of like what we did for number 3 on the... This could also be... remember that this is the same thing as arctan. Those mean the same thing. Tan -1 and arctan mean the same thing. And these are always in radians. Everything in 4-7, all those inverse ones are in radians. So there's 4 with the calculator. Everything else is without.
How many questions?
Yeah. 18.
Are we not realizing this when we come back?
Yeah, you'll have one more on this. So you use this part, right, to find theta. You don't know theta, or just to find the triangle. So I would put theta in the corner. Cosine would be adjacent hypotenuse. And then I got to find this missing side. So 2 squared plus x squared equals 3 squared. And then I want to find tangent of that same triangle. So now it's opposite over hypotenuse.
But there would never be a case that there's like, both of them have a -1 or both of them have arc?
No, one's got to lead you to the other. Yeah. It could be it could be the reverse. It could say tan -1 of cosine pi over 6.
So then you have to go on the unit circle.
So then this is going to be, well, that doesn't work because here it has to be like pi. Because you can't have both. This could be like pi, right? So the cosine at pi is 1. And then tan -1 of 1 is pi over 4. So the answer to this has to be a unit circle base for a tangent, which is where that gets There's a limited amount of questions that can be used like that. Like cosine and sine, you can use a lot because those get used a lot. But like tangent, the only time a value works for both cosine and tangent is if it's 0 or if it's 1 or -1.
When you write these, you just write the answer, right? It's not-
Yeah, yeah, correct.
So we could either like find it out if it's given to us like something on the unit circle, or if it's not, we just put in a triangle.
Yeah.
Every time.
Mm-hmm.